this is what we can do with the central limit theorem and the next z formula. Binomial distributions. What's a binomial distribution? Oh, right. That's one where there's only two things that can happen. Like flipping a coin. You get heads or tails. You throw a basket. You either make it or miss it. The two outcomes don't have to be equally likely, but there has to be only two outcomes. And we repeat the experiment over and over again and count how many successes you get. That's how a binomial distribution works. So, we had a formula for the binomial distribution, but it kind of took a long time to use. Like, out of the next 1,000 babies born at the university hospital, what is the probability that less than 550 of them are girls? We could do this using the formula, but it would be a really bad idea. We'd have to use the formula 550 times. I don't want to do that. Is there a solution? Yes! The central limit theorem says that no matter what kind of distribution you had to start with, if you take large samples, I would call 1,000 a large sample, you can use the normal distribution. Wait a sec. In order to use the normal distribution, don't we need a mean and standard deviation? Let's get some writing implements. So, we're wondering, out of the next 1,000 babies born at the university hospital, what is the probability that less than 550 are girls? We want to use the normal distribution, but we need a mean and standard deviation to do it. How do you find the mean of a binomial distribution? The mean of a binomial distribution. Right. Mu equals NP. Remember that from the last chapter? I know, it was a long time ago. What's the N? The number of babies. And P? The probability that one particular baby is a girl. So that's 1,000 times 0.5, which is 500. We expect that if we look at 1,000 babies, around 500 of them will be girls. That's why it's the mean. Square root of NPQ. What's Q? Q is 1 minus P. Here, it's also 0.5. So the standard deviation so that's the square root of 250, which works out to 15.81. So now we have a mean and we have a standard deviation. Now you can use the normal distribution. Now, we don't have to use the fancy z formula from the last lesson. We use the good old-fashioned z formula. So, we got this, we got this. What should your x be? Well, x is the number of girls that we're interested in, 550. Technically, we're going to use 549.5. Why? I'll come back to that. So, subtract, divide, what does that work out to? Yep. About 3.13. So, you take your z table, look for 3.13. 0.9991. So, very, very large. Because the problem said less than, this is your final answer. So, the steps we went through were find the mean and standard deviation, use the regular old z formula, use the table.